This is for the final. Uh, Physics, we have 3, which is recorded. 4, you have 4.1 to 4.13. I already have 4.1 to 4.7 recorded. فهلا بدي أسجل 4.8 until 4.13. From 4.8 to 4.12 ما في quiz. ف I'm just gonna I'm just gonna do the course division. It's pretty straightforward since there's no quiz for it. Uh, and then for 4.13 there is a quiz that is 19 questions. However, only 7 of those questions are new. The other questions are only 9 of those questions are new. The other 10 are literally they're just taken from other quizzes. I don't know why, and I've already recorded them. فyeah, let's start. أول شيء 4.8, given the meter stick is a negligible mass, find the force that will balance the stick and the resultant of the 2 downward pulls on the stick. Mass is 2 kilograms and 3 kilograms. So the first thing they're asking is, before starting, sorry, I have to shout out Ziad Turki from Sharjah. فشوت out to you Ziad Turki. المهم, let's start. Before starting, they want the single force that will balance the stick. إذا أنت عندك هون 3 kilograms, right? It's given 2 kg and 3 kg. So these are kg. I told you last time, don't solve using mass, convert it to a force. And to convert it to a force, W equals mg, so 3 times 10, so it's 30 newtons. And here 2 times 10, which is 20 newtons. Okay, so what's going to be the force that's going to balance the stick? If you have 30 here, 20 here, to balance that, you're going to need 50 newtons. But when they say find the force that will balance the stick, a force is a magnitude and it's a direction. Okay, so we gave the magnitude, which is 50. Hello, we have to tell them where is this force going to be. Okay, طب نحن we want to balance the stick. Balance the stick means that means the stick won't be rotating since it's balanced. Okay, and if it's not rotating, that means sigma m is equal to 0 because there's no more rotation. It's sigma m equals 0. Sigma m equals 0 means the total moment is 0. We have 3 forces here, and our sigma m should be equal to 0. Okay, what's one way to do it? Another way I showed you last time was take either end of the stick as your point of moment. Okay, you can take either point. Usually I told you take the point that they're asking the distance from that point. In this case, it doesn't matter since they're not asking for the distance from somewhere specific. So you can pick either here on the left or on the right. I'll take on the left. So let's take this as our point of moment or our point of rotation. So we have 3 moments, right? Our first moment, let's call it moment 1. It's going to be equal to 0 because it's coinciding with the point of moment. And remember, when it coincides, yani the moment of that is 0. How about moment 2, which is for the 50? This 50 actually is moving counterclockwise. So it's going to be plus 50 times d perpendicular. We don't know how much the length is, right? So we keep it as L. How about moment 3? Moment 3, it's actually minus 20 times 1. You're gonna tell me, Walid, why minus 20? Why times 1? أول شيء minus 20 because it's gonna be going clockwise. If you want to see why, draw both sides. Remember the way I told you. Draw from here, draw from here. Red line is quicker. It's more straightforward. It's more straightforward. First, the shorter path, and that's clockwise. It's moving like this, so it's negative. So it's negative 20 times 1. Why 1? Because the distance between it is 1 meter. Okay, remember it has to be in meters because they said it's a meter stick. Meter stick meaning the whole stick is 1 meter. So these are our moments that we know that sigma m is going to be 0. Okay, so that means 0 plus 50L minus 20 equals 0. So it's going to be 50L equals 20. and then L equals 20 over 50, which is 0.4 meters. So you're gonna say, well, you 0.4 meters from where? It's gonna be 0.4 meters from the distance of the point of moments you took. Since we took this as our point of moments, and here at 0.4, that's gonna be where you're gonna place the force to balance it. Question 14. Unknown battery part B. What's gonna be the resultant of the two downward pulls? We said one pull is 30, one pull is 20, so the resultant is gonna be 50. The center of gravity. For the center of gravity, there's a formula you need to know. It's actually W1 over W2 equals the distance between the center of gravity of the object to the center of gravity between both of the object. So GG2 over, again, the distance between the center of gravity of the other object between the center of gravity of the system. So GG1. This is how the formula is. So since you guys want me, I remember someone said, say to balance, that means someone told me to write down the formulas, so I will write them down now. Sigma m equals 0 if it's balanced. بعدين we said the center of gravity formula, center of gravity is weight 1 over weight 2 equals GG2 over GG1. Okay, they're saying there's centers of gravity A, B, and C, okay, of three bodies. This is one center of gravity, this is the other center of gravity, this is the third center of gravity. Okay, they constitute a system S that forms an equilateral triangle of side A. So you can look at it like this: A, B, C, and each side is 8 centimeters, 8 centimeters, 8 centimeters, and each one has its own mass. A is 0.3 kilograms, B is 0.1 kilograms, and C is 0.4 kilograms. Find the center of gravity of the system S. Okay, the way they did it in the solution, it's pretty interesting. I like the way they did it. Okay, أول شيء keep the heavier side last. Okay, let's work with the smaller two sides. You're gonna need a center of gravity between these two, and we're gonna compare that center of gravity with the center of gravity of this one. Okay, so how would you find the center of gravity between A and B? Let's apply the formula. Weight 1, let's take A as weight 1, which is gonna be 3. Why not 0.3? Because we multiplied by 10, because W equals mg, mass times gravity. 3 over weight 2, so let's take B, it's actually 1. GG2 and GG1, we don't know. They represent how far to the center of gravity. That's what GG1, GG2 is. But let's keep it as GG2 over GG1. If you cross multiply, you're gonna get that 3 of GG1 is equal to 3 GG2. What did I say? Is equal to GG2, not 3 GG2. Okay. Also, you need to know that when you add GG1 plus GG2, what do you get? You get 8. Why are you going to get 8? Because that's the length of the side of the triangle, which we said is 8. So that means GG1 plus GG2 equals 8. Okay. Do we know what GG2 is? Yes, we do. It's actually 3 GG1. So let's replace GG2 with 3 GG1, and it equals 8. You get 4 GG1 equals 8, and you get GG1 equals 2 centimeters as the meters. Now you know that you know where the center of gravity is. Okay, so GG1 is 2, that means هيدي it's on 2. Okay, طيب, GG1 is the center of gravity for which two, A and B, right, which have a collective mass of 0.4, because 0.1, 0.3. However, they want the center of gravity of the whole system S. We're missing one side, and that side's side C, right? Side C, uh, we want to find the center of gravity for side C because we need the whole system. Okay, here's what you do. Side C actually has the same weight as the center of gravity over here, 0.4. Why does this was 0.4? Because 0.3 plus 0.1. And it has the same weight. So what does that mean? Their center of gravity will both fall on the same line. So it should be, uh, yeah, if you connect them both, and the center of gravity between those two, since they're the same mass, it's going to be in the midpoint. It's called G prime. It's going to be in the midpoint of uh, the line connecting the two center of gravities, since they have the same mass. So that's how you find the center of gravity. Question 15. A pin is formed of a spherical tip of mass 5 and a radius 1 attached to a point A to a uniform rod of mass 10 grams and the length 8 centimeters. This one here has a mass, the tip, it has a mass of 5 grams and the radius is 1. This is 1 centimeter. It's attached to a point A of a rod which has a mass of 10 grams. So this rod is 10 grams and its length is 8 cm. Find the center of gravity of the pin. So similar to the last question, if you have a whole system, to find the center of gravity of the whole system, you're going to need the center of gravity of both systems, and then you're going to find the center of gravity in between them. Okay, because remember the formula is W1 over W2 equals GG2 over GG1. Okay, so that means you need the center of gravities. G's are the G1 and G2 are the center of gravity of each individual object. So if you want to find the overall center of gravity, you're going to need the center of gravity of each one. Okay, so let's take a look at the rod. Yeah, the rod has a length of 8 centimeters, and obviously, if it's just a rod, where's the center of gravity going to be? It's going to be in the middle. 4 centimeters because it's a uniform rod, so that means the mass is distributed equally among the whole thing. So if you just have a straight line, uh, the center of gravity of any straight line is just going to be in the middle. So if the whole thing is 8 centimeters, that means this is going to be our center of gravity. Let's call it G1. Okay, then we have the center which is positioned 4 centimeters. Then we have the center of gravity of our sphere. The center of gravity of any sphere or circle is obviously going to be in the center of the circle. Okay, so let's call that center of gravity over here G2. Okay, and you know this distance is 1 centimeter, and then this distance over here is 4 centimeters. Can we find excuse me, can we find the center of gravity of the whole thing now? I think yes, we can. So what will you do? Let's plug in the formula now. Let's start with weight 1. Okay, weight 1, we're talking about the rod because G1 is weight 1. Is that G1 is the rod. So let's see. Weight 1, you know, W equals mg. Okay. Uh, the mass of the rod is 10 grams. So we'll write it as 0.01 because it has to be in kilograms. So you divide by 1000. So 0.01 times G, which is 10. G is always 10 unless they tell you it's something else. Okay. 0.01 times 10, you get 0.1. Okay, so W1 is 0.1 over W2, which is 5 grams for the mass, so 0.005 times 10, and you get W is 0.05. Yeah, uh, over here, 0.05 equals GG2 over GG1. Okay, here's the thing. Instead of writing this 0.1 over 0.05, this actually as a number, by the way, is 2. Okay, 0.1 divided by 0.005, it's 2 if you do it on a calculator. Okay, 2 equals GG2 over GG1. How do you solve this? If you cross multiply, you know, you get 2 GG1 equals GG2. Okay, so we get this equation here. But if you want, after this I'll explain the steps for an easier way. So you get this equation here. And what else do we know about this center of gravity here? We know that it's 1 centimeter here and 4 centimeter here. So we know that if you add GG1 plus GG2, how much would you get? You're going to get 5 centimeters. Why? Because 1 centimeter plus 4 centimeters, 5 centimeters. So when we talk about GG1 and GG2, we're actually talking about the distance, okay? So can you solve this equation? It's just math. If GG2 equals 2GG1, that means here, instead of GG2, we can write 2GG1. And here you have GG1, right? From GG1 plus 2GG1, because GG2 is equal to 2GG1, so you just substitute it, equals 5 cm. So you get GG1 plus 2GG1 is actually 3GG1, equals 5 cm. And then you get GG1 equals 5 over 3 centimeters. The distance between the center of gravity and the center of gravity of object 1 is actually 5 over 3 centimeters, which is 1 point, I think 6, it's 1.67. But it's going to be over here. This is going to be a distance of 1.67 because 5 over 3 is 1.67. Okay? And then obviously, how would you find the rest of it? You just do, since the total is 5, you just do 5.1.67. You get, I think you should get 3.33, 3.33 centimeters. Okay, that's يعني it's how you solve it. If you want, for those who are a bit confused, if anytime you want to solve a center of gravity question, whenever you have two objects, you need two equations. You need two equations. You need the multiplication, the product equation. I'll call it the product equation. Okay, the product equation, and you need the sum equation. Okay, the sum equation. The sum equation is very simple. It's how do you find the sum equation? You just add the distances. You just add the distances. And then how do you find the product equation? You have to apply W1 over W2 equals GG2 over GG1. Notice how they're not the same. So it's, if up here is W1, that means down is GG1. Okay, if here down is W2, then up is GG2. If you get what I mean, they're opposite. Yeah. So the product equation is when we got مثلا 2GG1 equals GG2 for that last step, if you remember. And the sum equation is when we said GG1 plus GG2 equals 5. So if you can get these two equations, then finding G is super easy. Okay. So that's what you need two things to solve: the product equation and the sum equation. After you find them, then it's all easy. 4.10. Given a uniformly thin flat object of irregular shape, what is the best way to find its center of gravity in the lab? Okay, I don't think this will come. Not written, maybe multiple, but you have to memorize it. Okay, there's a few rules. What's the speech? What did they ask to find? Find the center of gravity of the pin. It was, yeah, مش نحن we got 1.67. Yeah. So what did they want? BG pro? Ah, they wanted the center of gravity. Okay, my fault. So we found it, yeah. We said that no, G1's here and G was here. We said it's 1.67, right? Yeah, I mean, technically, what do they want you to do with the 1.67? Ah, they want you to find, yani, okay. Find the center of gravity of the pin. So they basically want you to find how far it is from either A or from B. Okay, if you want, you can say BG equals 1.67 plus 4. Or if you want, you can say AG equals 4 minus 1.67. I think you know why. Because here is 4 centimeters, here is 4 centimeters. AG would be 4 minus 1.67, but BG would be 4 plus this 1.67. So they use BG. You can use AG or BG. It depends. Why are we doing this? Because they said find the center of gravity of the whole pin. Okay. I just say, honestly, after you find 1.67, just add plus 4. المهم, for the experiment part, you just need to memorize this. I think I showed this in my AMS recording. Suspend the object from a fixed point. Okay. So if you have this paper, okay, you want to find the center of gravity of this paper. You're gonna hang it from here. Okay. and you're gonna hang it, wait for it to set in equilibrium. Okay, يعني wait for it to stand still. After that, draw a diagonal. Okay, then use another point, draw the diagonal, then draw another diagonal, whatever. Okay, they're all gonna intersect at one point. Okay, let's say they all intersected here. That means this point is the center of gravity. Okay, 4.11. You have a uniform meter ruler AB of weight 0.95 newtons is supported on a knife edge over here, placed at 45 centimeters from A. The meter ruler bounces horizontally when a mass of 48 grams is suspended at a distance x from A. Find the value of x. Okay. So for this question, what you're required to find is this distance x. For what you need to do here is we have three forces acting, okay, and usually you'd have to figure out what are the three forces, but here they kind of drew it for you. You have the weight, you have the tension, you have the normal. The weight they said is 0.95. uh, they said the meter ruler bounces horizontally when a mass of 48 grams is suspended. So this here is 48 grams, okay? And a million times I keep on telling you guys, it came in the CA and you guys got it wrong because you forgot to convert to newtons. When solving these types of questions, please convert it to newtons. Okay, convert it to newtons by doing W equals mg, mass is 0.048, and then multiply by 10, you get W equals 0.48 newtons. So شو W قصدي yeah, weight يعني the force doesn't necessarily mean W as in here the W, it means يعني the force. What is the force? Okay, you get 0.48. Always convert it to newtons, please. Even in written, if you don't convert it to newtons, you're gonna get it wrong. Even if you end up with the correct answer, the method you use is wrong. Okay, and then you have this normal force, and the normal force is basically balancing out these two forces. So what's going to be the normal force equal to? It's going to be equal to 0.48 plus 0.95, which is 1.43. Okay, so if you remember the steps I used to give you when solving these types of questions, step one was to identify all three forces. So yeah, my fault. After identifying all your forces, you need to, step two is to take a point of moment. Okay. In this case, since we want to find the distance x, which is between A and T, let's take A as our point of moment. Okay, so since we're saying it's balanced, that means sigma m equals 0. So when you add up all the moments, it's equal to 0. So let's start. We have three moments in this case. Let's start with the moment t. The moment is FD perpendicular. So let's call it the moment of t. What is it going to be equal to? Negative 0.48. Why negative? Because it's obvious. It's going to go clockwise, right? So negative 0.48 times distance perpendicular. What's the distance? X. So let's keep it as negative 0.48x. Let's look at the moment of the weight. Here's the thing. The weight obviously is going to go clockwise, right? Because it's moving like this. It's going to go clockwise, so it's going to be 0.95, negative 0.95, sorry, times the distance. Okay, the distance is going to be this, right? Now here, please listen to me and listen carefully. Whenever you have a weight of any object, the weight it passes through the center of gravity. Okay, it passes through the center of gravity. So the center of gravity in a rod, like I told you in the last question, it's halfway through. For the weight is going to be halfway through. It's going to be 0.5. Okay, 0.5. Why, by the way, why you're gonna tell me, why aren't you using 50 centimeters? Because you need to use meters, huh? Please don't use centimeters when solving. Please use meters. And finally, the moment of n, which is gonna be the force n, which goes counterclockwise, so we keep it positive. 1.43 times the distance, which is given 45 centimeters, so 0.45. We know that sigma m equals 0, so that means when we add all of this up, we're gonna get 0.45. Let's clean it up a bit. Minus 0.48x stays as minus 0.48x. Minus 0.95 times 0.5 minus 0.95 times 0.5. You get minus 0.475. And then 1.43 times 0.45 is 0.6 0.6435. So plus 0.6435, you get equals to 0. Okay, uh, clean this up a bit. You're gonna get, subtract these, 6435 minus 475, you get 0.1685, so minus 0.48x plus 0.1685 equals 0. Move the 0.48x to the other side, you get 0.1685 equals 0.48x. You divide by 0.48, you get x equals 0.1683, 1685, sorry, uh, over 0.48, and you get 0.3, am I correct? Yeah, you get 0.35. It equals 0.35, and it's a long decimal. If I just keep it as 0.35, two significant figures, because everything here is two significant figures. So you get 0.35 meters. They want it, you can keep it as 0.35 meters. If you want to convert to centimeters, it becomes 5 centimeters. Okay, 18. It's it's very easy. Okay, they're giving you the distance, they're giving you the force. Okay, he's pulling at 90 and he's pulling at 120. Okay, at 90 degrees, it's gonna look like this. Pulling with a force of 50 newtons. The distance is 24 centimeters, so it's 0.24 meters. It's very, very simple. Okay, how would you find the moment of this? It's very easy. It's 50 times uh, 0.24. Well, I'm not sure if they need the positive negative. They don't. Okay, because they're just staying like this. They're giving you the angle. So, they're asking, wait, what difference will it make? Yeah, because they're talking about two different moments. They want to find the difference. No need, just put FD. Okay, 50 times 0.24, you get, what was it? What was the answer? 12. Okay, 12. 12 Newton meter. Okay, this is the unit for moment. In case it comes in the written, it probably will, but it's the unit. 12 Newton meter. And then they're saying he pulls at 120. The other case is like this. Not like this. Like this. 120 degrees. Okay. So what if between his arm and the spanner is increased from 90 to 120? So here's how you do it, yeah? They want distance perpendicular, obvious, all the time, right? So in this case, the moment is the force 50 times the perpendicular. But is it perpendicular if the angle is 120? Obviously not. And this came in an AMS. Not like this, but the same concept. If you have an angle like this, okay, if they tell you it's like this one between the force and the object is 120, okay, you're gonna do 50 times sine 180 minus the angle. Okay, if it's like this, but if they gave it to you like this is the force, the point of moment is here, and they give you the angle 60 here, you directly do 50 times sine 60. If they give you the opposite angle, okay, if you want to know the proof, it's because you need the angle over here to find the perpendicular. Okay, you need the angle here. This angle here is equal to this angle here, and this angle here is 180 minus this angle. That's just the proof if you want to know. But sorry, not sine, it's the force times as the distance times the sine, and here again distance times the sine. So in this case, what I'm going to do is, let me not bore you. Since they gave us that the angle between the force, his arm, the force, and the spanner is 120, and this is 50, and this is 24 centimeters. Okay, the way you're going to do it is going to be 50 times sine 180 minus 120 times the distance, 0.24. Or other people can write it as 50 times sine, 50 times 0.24 sine 60. Other people write it like this. Okay, and you're gonna get 50 times 0.24 sine 60. You're gonna get 10.4. So they're saying what happens? What difference would it be if you're increasing the angle? Okay, the moment decreases. You just say the moment decreases because from 90 it was 12. Here it became 10.4. What happens once you increase the angle? You say it decreases. That's it. Okay, question 19 shows a man, again, he has a mass of 90 kilos. He's walking on a beam of mass 80 kilos. Okay, pay attention, it's a uniform beam. Okay, the beam is hinged at A, so it's hinged over here. This is the point of rotation, and hung at B. by means of a cable that can withstand a maximum load of 1000 newtons. How far can this man move before the cable breaks? So we need to find, where can this man, and how far can he move on this beam before the cable it pops. Okay, so we want to know uh, right before the cable pops, there's going to be no moving, right? That's the maximum that he can walk, if you get what I mean. So he's going to keep on walking along this beam until he reaches the maximum. Okay, pay attention that once he reaches the maximum, just like right before it pops, the beam still doesn't move. So there's no rotation. So what does that mean? Again, sigma m equals 0. Because the cable, yeah, it's still in inertia, it's not moving, it's not rotating. But that means the moments are still equal to 0. The sum of moments are equal to 0. Whenever you're balancing something, the sigma m always equals 0, like the other questions. So let's see here. What's the first thing I told you want to find whenever you're solving sigma m equals 0? You need to find all the forces. What's the first force? The mass. The man has a mass of 90 kilos. So obviously the weight of the man, which is 900. Why 900? Because W equals mg, you multiply by 10. And it's already in kilos, so there's no need to convert. So 90 times 10, 900 newtons. The second force would be the beam has a mass of 80 kilos. So obviously the weight of the beam, which is going to be 800, because 80 times 10, W equals mg, 800 newtons. It's important to, okay, no, I'll skip that part. And then our other force is going to be 1000 newtons, which is acting upwards like this, 1000 newtons, because it's the rope pulling it upwards, right? Okay, so we identified our three forces. What's the next step? We have to find the moment of each one. So let's call this one the weight of the rod, and then we call the man, and then the rope. So we have the moment of the weight, the moment of the man, and the moment of, what was the rod? The cable, the cable. Let's start. The moment of the weight. The weight, it's gonna go clockwise, right? It's going like this. And I'm not drawing, I'm not showing you the way to figure it out, because I've showed it many times. If you want me, I need to show you again. You draw one like this, and then you draw another one. Obviously, the red one is short, if it's gonna go clockwise. So just for the people who forgot, and I wasn't showing you because I thought, خلاص, you guys know. For the moment of the weight is going to be equal to minus 800, because we're going clockwise, times the distance, which is 3. Okay, Willie, why is the distance 3? Okay, this rod is given that it's 6 meters, right? And since we said it's a uniform beam, what did I tell you? The weight acts in the midpoint, halfway between them. The weight is always on the center of gravity, so in between them, in the middle. So this weight is going to be at 3. So half of 6 is 3. Equals minus 2400. The moment of the man, again, it's acting downwards, so it's going to be also clockwise, right? So minus 900 times the distance. We don't know the distance, right? We're trying to find it. صح? That's what we're trying to find. And how far can the man be? So minus 900d. And the moment of the cable is going to be counterclockwise, which is so positive 1000, times the distance, which is 6, because it's 6 meters away, right? So it's going to be 6000. So let's simplify this. Sigma m equals 0. That means this plus this plus this equals 0. So minus 2400 minus 900d, because minus 900 times d is minus 900d, plus 6000 equals 0. Simplify this, minus 2400 plus 6000. It's going to be, what's 3600? Yeah, 3600. For minus 900d plus 3600 equals 0. Take minus 900 to the other side. You get d equals 3600 over 900. So d equals 4 meters. 4 meters away from what? From the point of rotation you're taking. So we're taking A as the point of rotation. So 4 meters away, that's where the maximum is. Okay? And that's the answer. Yes, it is. Yeah, here they said we're getting negative and positive because of clockwise and counterclockwise. Okay. 4.12. A man of mass 70 kilos is standing on a plank of mass 100 kilos, resting on two trestles as shown in the diagram. Knowing that, let me go down. Knowing that the plank is homogeneous and uniform, let me zoom out. Find the magnitude of the vertical forces acting by the two trestles when the man is 2 meters from A. Find these forces when the man is standing straight at B and at D. What's that? So let's call this part A. I don't know why they didn't put A, B, C. They're saying, knowing that the plank is homogeneous and uniform. Find the magnitude of the vertical forces acting by the two trestles when the man is 2 meters from A. Okay, here's the thing. They want the magnitude of the vertical forces. So the vertical force, and they want the forces that are going up. Acted by what? By the trestles. Okay, obviously, if you put a weight here, the only thing opposing it would be from here and from here. But one of them has a higher force than the other, and let me show you. Actually, they're saying the mass of the man is 70 kilograms. So in newtons, that's 700, because 70 times 10. And the mass of the plank is 100 kilograms. It's over here. It's going to be 1000 newtons. Okay, so if these are the forces acting downwards, you know that the sum of the forces, they should cancel each other out. So if you have 1700 down, yani you should also have 1700 up. But you can't say this one is 1000. You can't say this is 850 and this is 850. You tell me, Walid, why? When they add up to 1700, well, akid no. One of them is heavier than the other because the man is closer to one of them than the other one. فالمهم, we have B and C. So we identified our forces. Our forces are ما we have the force of the weight of the man here and the weight of the plank. Okay. In addition to that, like we said, there's a force from B and there's a force from C. These are the forces now. Okay. Not only these two and a third force, no, you also have these forces that are acting upwards to cancel out the 700 and 1000. So how would you find this? Let's see. Uh, for the sake of the man being closer to B, I'm gonna take B as my point of moments. Okay, so let's solve this. They said the man is 2 meters from A, so this here is 2 meters. Okay, so let's start. That means we know that it's balanced, right? So that means sigma m is 0. So that means all of the moments should be equal to 0. So the moment of B on B is 0, obviously, because it cancels out. And if you're taking look, it coincides. The line of action of B for the force B, it's 0. And then the moment of the man, let's say the man on B, what is it equal to? The force, which is minus 700 because it's going clockwise. It's going down clockwise. Okay, minus 700 times D perpendicular. D is 1. Okay, you can tell, Willie, why is it 1? Okay, the man is 2 meters away from A. B is 1 meter away from A. So can you find this segment here? If this is 2 and this is 1, obviously 2 minus 1, 1 meter. Okay, 700 times 1. Now the moment of the weight on B, the weight, it's going to be minus 1000 times 1.5. What do you guys 1.5? Look, you have this segment here, right? The plank is uniform. Okay, if it's 3 meters, where's the weight going to be? It's going to be 1.5. Why? Because it's halfway. ألف مرة صرنا هنا. So the moment of the weight around B is going to be here over 1000. It's going to be minus 1000 times 1.5. How about the moment of C on B? It's going to be the force of C. Let's call it for FC times the D perpendicular, which is 3. And it's positive. Why? Because it's going like this. Okay, that's 1, 2, 3. Yeah, that's counterclockwise. That's why it's positive. So if we add these all up, we're gonna get 0 because sigma m equals 0. Let's cancel the 0 out. No need to put it. Minus 700 times 1 is minus 700. Minus 1000 times 1.5 is minus 1500. Plus 3fc equals 0. You're gonna get 3fc equals 2250. Well, 700. 2200. You get 2200. So FC is going to be equal to 2200 over 3, which is 733. So FC is 733.33 أكيد. Let me see if that answer is correct. Force of C. When question 20. The force of C. Yeah, 733. So now we know the force of C. They want both of the forces acting by the two trestles. So they also want the force of B. If we have the force of C, which is 733.3, can we find the force of B? Akid we can, because we said they have to add up to 1700 to cancel out the forces that are under. For 1700 minus 733.33, you're going to get F of B equals 966.7 newtons أكيد ده. Yeah, 966.7. For part B, uh, they're asking, uh, find the forces again in two other cases, when he's standing at B and when he's standing at D. Okay, طب let's say this man now he's here, right? Okay. Uh, Again, his weight is 700, and the weight of the plank is 1000. They want again to find the forces. Okay, same thing. We're gonna use sigma m equals 0, but it's a bit easier now because the man's at B. So that means the moment of B around B, which is 0 obviously, because the moment of B, the force of B, it's coinciding with B, since we're taking B as the center of moment, it's 0. Then the moment of the man around B, again it's 0, because why? The man is actually standing on B now, for the force coincides with the axis of rotation, so it's 0. Remember, when the force coincides with axis of rotation, then the moment of it is 0. Then we have the moment of the weight of the plank, which is 1000 around B. Same thing, it's minus 1000 times 1.5. And then we have the moment of C around B, which is equal to the force times 3. It's positive, same as last time. So let's add these all up because it's sigma m. So let's cancel the zeros, no need to write them. So you get minus 1500 plus 3f equals 0. You get 3f equals 1500, fc, huh? Fc equals 1500 divided by 3, which is 500 newtons. 500 newtons for Fc. We want to know Fb. We do 1700 minus 500 because the total force is 1700. So it's going to be 1200. Let me check if this is correct. Yes. Okay. Then they want when the guy is standing at D. When the guy is standing at D. Again, same thing. So the guy's here now, yeah? Let's take B as our point of moment. And we'll do sigma m equals 0. The moment of B around B. We have four forces, remember? The weight of the man, the weight of the plank, the force of C, and the force of B. The moment of B around B, again 0 because it's coinciding. The moment of the weight of the plank around B, again it's minus 1000 times 1.5. And then the moment of C around B is the force of C times 3 again. And then the moment of the weight of the man, is equal to 700 minus 700. Remember, it's 700, yeah? For the weight, it's 70 kilos. Minus 700 because it's clockwise times the distance, which is 4 now, because you have this 3 meters and you have this 1 meter. Okay, so let's add these all up. Minus 1500 minus 2800 plus 3fc equals 0. So 3fc equals, take these to the other side and add them. It should be 1500 plus 2800. You should get 4300. And you get fc is equal to 4300 divided by 3, which is 1433.3. Let me check if this is correct. Yes. And then to find fb, the force of b, you do 1700 minus the answer, which is 266.67, or 266.7. Okay, newtons, huh? Always newtons. Put the unit, please. Always put the unit. If the trestle at C can be moved towards B, what is the position beyond which the plank will topple when the man is at D? So the man is at D. So they want now for the last part, part C or whatever. They're saying that the plank will topple. Topple means يعني the guy standing here. What's gonna happen? The plank is خلاص, it's gonna how can I say it? It's gonna start move. It's gonna rotate. Like the plank's actually gonna fall. In this case, so it's gonna rotate like down, and خلاص, it's gonna start going. It's gonna look like this, the plank. And then B is gonna be here. So B won't be touching the plank anymore, if you get what I mean. So the plank starts going up. So they're saying at what distance what's the position? What distance will that happen? So again, you have to understand that the moment sigma m equals 0. Okay, but sigma m in under what conditions? Before looking at sigma m equals 0, I want to show you that the force of B in this case is going to be equal to 0. Wait, why is the force would be equal to 0? Okay, if the plank is toppling, it looks like this, C, and it looks like this, B. Is there any force of B if it's not touching the plank? Of course, there's no force. If the force of B is 0, what will the force of C be? 1700. Why? Because I told you that if it's 1700 down, yani 1700 up. But if here's 0, yani here all of the force will be concentrated at C, 1700. Okay, if you have, now we have the forces. We have the force of C is 1700, and we have the force of B is 0. Now let's find the moment around B again. The moment of B around B is obviously 0, because the force is 0 and it's passing through B. The moment of the weight of the plank around B is again minus 1000 times 1.5. The moment of the man around B, again, it's minus 700 times 4. Same as the last part. بعدين المومنت تبع C around B is gonna be 1700 positive because it's going up clockwise as the counterclockwise times 3. So let's solve this. Uh, wait. What should we? Not times C, times a distance D, because we're moving the plank C. We're moving it somewhere now, right? So we don't know where to put it. So that's why times D. We don't know the distance of it. We're trying to find the plank of C, the plank C. If you add all of these up, we're gonna get 0. So let's not write this. It'll be minus 1500 minus 2800 plus 1700 D equals 0. Is gonna become minus 4300 plus 1700 D equals 0. Take this to the other side. 1700 D equals 4300. You divide, you're gonna get, let me do it, 4300 divided by 1700, you get 2.53 meters away from B, I think. Oh, 2.53 meters from B. Why from B? Because it's 2.53 meters away from the point of rotation that you're taking. Okay? Sometimes they might ask you how far is it from A. So that means you take A as your point of rotation. Okay? دايما. But right now B was our easiest point because that's where the other force is. I took that for all of the parts. Okay. This question 21, I can see it coming in the written wallah. I feel like to bring something like this. If you want, I'll give you the steps. There's a very easy way to do it and no, how can I say it? No, هيك without writing rules and ما بعرف شو, but in the written you always have to show your work. Okay, so we have a girl of 50 kilograms at a distance of 3.4 meters, and another one, they gave you the weight is 450 newtons. At what distance? For the written, uh, you can write, no, the the way they say it in the course, and they say the anti-clockwise moment is equal to the clockwise moment. You can also say sigma m equals 0, whatever you want. I like using sigma m equals 0. Okay, I'm gonna put sigma, what? That's not sigma. Sigma m equals 0. And there's two moments, right? You have the moment on the right hand side and the one on the left hand side. Okay, to imagine it, this is if you want in the written now. In the written, you have the 50 kilograms here, so that's 500 newtons, and you have the left side, which is 450 newtons. You have the center over here. Okay, yeah. So, this one, the the one on the right side is 3.4 meters away by 3.4, and we want this distance x. Okay, so that means let's find the moment of the left side. It's equal to, it's going counterclockwise, right? Going counterclockwise. So it's going to be positive 400 times x, and the moment of the right is negative 500 times 3.4. Why negative? Because it's going clockwise. Okay, so it's going to be negative 500 times 3.4, which is so we said sigma m equals 0, so يعني once you add these you're gonna get 0. So 400x minus 1700, because minus 500 times 3/4 is minus 1700, equals 0. You get 400x equals 1700, x equals 1700 over 400, cancel, 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 17 over 4, which is 4.25. So x equals 4.25 meters. Let me see if this is correct. What? They got 3.8. They got 3.8. What am I doing wrong? Mm. And why did I put 400? Hold up, hold up. I put 450. My fault, my fault. 450 times x. And this is 450. This is 450. This is. Yeah, let me erase this. Ya Allah. Yeah, yeah, it's supposed to be 450. So 400, so 450x minus 1700 equals 0. 450x equals 1700. X equals 1700 divided by 450, which is equal to 3.8. I think. Let me see. 1700 divided by 450. It's 3.778. But yeah, just keep it as 3.8 if they want two significant figures. Depends on what they ask in the written. 3.8 meters. If you write it like this, you can get full. If you write it like this, you can get full. I don't know why they're writing it like this. They're saying mg, which is because you have to do w equals mg, to convert it to newtons. And this is w equals mg. Show them how you got 500 newtons for 450. 450 is given, but show them how you got 500 newtons. Say 50 times 10. Okay, equals 500 newtons. Show them this part. Okay, because the person correcting no might uh, deduct marks if you just put 500 newtons like this. Honestly, I don't know. It depends on who corrects for you. And maybe if you just write 50 times 10 equals 500, they say, why? Why are you doing 50 times 10? Say w equals mg, because they're saying g equals 10. So, whatever you want, because uh, you have this way or you have this way here. I don't like their way, to be honest. I like my way more. Sigma m equals 0. Just add them all. You get 3.8 meters. Always include the unit meters. I think هيك خلصنا الكورس. خلصنا الكورس. هلا على الكويز.